In this video, I'd be talking about basic Java programming, or rather, the basics of Java programming. Um, Firstly, legal identifiers might start with a currency character or a connecting character. Since Java code conventions are very well known to you, Java Beans naming standards, so Java Beans support properties as well as listeners, and all these methods should be public. So say for example, if there is a property by name size, in order to get the property, you would say get size. So you'd say public return type, or the type of size, get size, and return size. So this is a getter method, and getter method for booleans could be a get. So the boolean name, the boolean variable name could proceed with get or is. So you could say public boolean is stopped, and you return stopped. This is an example of a setter method. They are public too. They have void return type. They take in an argument, so which is of the type size. So size is long, so is s. So you assign s to size. So that's a setter method. Let's take a look at listener naming rules. So listeners are the objects which listen for events. Um, and listeners are tied to event sources. So they should be public too. This is the way you would add an event listener to an event source. So you would say public void add what listener it is. So it could be a mouse listener, it could be a keyboard listener, or mouse move listener, mouse click listener. So add listener type listener, and then the type a listener. So a listener is of type XXX listener. Um, so that means the type could be this as such, or any class down the hierarchy with this as the parent. So basically, this type could be a subclass of this type. So this type could be a subclass of this type, right? Okay. This is the way you would remove a listener from an event source. So remote again, XXX listener type a listener. Okay, so right. How can a class in Java be accessed? A class in Java could be accessed using an instance of the class, or through inheritance. Access modifiers. Therefore, there are three access modifier keywords, but there are four access modifiers. There are three access modifiers, but there are four levels of access. Public, private, protected, default, or the four levels of access. But public, private, protected are the access modifiers. Explicit, default is implicit, or by default. Non-access modifier, not non-access modifiers. Strict FP, final abstract, just to name a few. So on classes, I could apply public, default, access modifiers, final or abstract or strict FP, non-access modifiers. On method arguments or local variables, I can access only final. I could apply only final. On variables which are non-local, and which are declared within the class, it could be final. It could be public, protected, private. They could be default as well. Static, transient, and volatile. On methods, I can have final, public, protected, static, private, static, abstract, synchronized, strict FP, to make it compatible, to make the floating point or the floating point representations compatible with IEEE 754 standard. A native method is a method implemented in a platform dependent code. Interfaces could be public, could have public and default, or public or default access modifiers. Um, any variable declared within an interface is a constant, so they would have public static final modifiers attached to them. Methods are public and abstract. Interface methods must not be static, because interface methods are abstract. They cannot be marked final, strict FP, or native. If you have a private method in class parent, and the child seems to be redefining it, but it's not exactly redefining it. You're not overriding this method, but you're just defining a method which accidentally seems to have the same name as this one, right? So overriding is when you inherit a method and redefine it, but private methods are not inherited, so you cannot say method 1 here is overriding this method 1 of the parent class. Let's take a look at access modifiers. Within a class, you can access um, uh, all four access modifiers, or all variables declared with any one of these four access modifiers. So within the same package, but not a child, right? So that is um, uh, class A and class abracadabra are in the same package, which is P1. So all these classes are defined in A.java, right? So in A.java, I have A abracadabra and as A's child, which is extending A, right? So within the same package, so that is abracadabra and A are in the same package, right? But abracadabra is not a child of A. So in that case, um, I can I can access the public variables of A using containment. So using an instance of A, I could access the public variables of A. I can access the protected members of A using um, containment. That is using an instance of A, just like here. I create uh, I create an instance of A and use the instance or the reference to refer to I. So I can access the protected member using containment, but not through inheritance, right? Because abracadabra is not extending class A. And the default members could also be accessed using containment. So this is a default member of A. I can access J is a default member of A. I can access J through A, an instance of or a reference of A. So A.j is valid. Private members cannot be accessed from anywhere except for within the same class. Right now, same package but a child, which is A's child, is a child of A. So you can access it using containment as well as inheritance. So this is through containment, this is through inheritance. So it's the case with default members. J is a default member of class A. I can access J using containment, also through inheritance, like this here. Now different package but not a child, right? So now class F is in a different package, which is package P2. Now, sorry, but not a child. So let's take a look at you can only access public members using containment. You cannot access protected, default, or private. Different package but a child. You certainly cannot access default because they could be accessed only within um, the same package, But you can access public using containment, and certainly inheritance because it's a child class. So you could declare an instance of the parent class and access the member through containment, or you could directly use it because the public members are inherited to the child members. Protected could only be accessed using inheritance. So if we could look at this example, now class F is in a different package, which is extending A, which is in a different package. So F is in P2, package P2, and A is in package P1. You create an instance of A. You cannot do any one of these operations, or you cannot access I, J, or J in this way. You can just access I as such because it's inherited, because I is a protected member of A. um, when you extend A, the protected members could be accessed only through inheritance but not through containment. So this is incorrect. This is correct. Now I is a protected member in F. So you could think that by creating an instance of F in a different class, you can access I, but that is incorrect. Uh, even though I has a protected access in F, and so does P, you could do A dot P but not A dot I because I is from a different package, right? So because I is from a different package, the only way you can access it is through inheritance. So if I have F's child extending F, I can access I as such because it's inherited. But as you can notice, because P belongs to this package, you can access P using containment or inheritance. So same package, unchild, you can access protected members using containment plus inheritance. Same package but not a child, you can access protected using containment, right? So same package, so fan is in the same package as F, and I is a protected member, so that means you should be able to access I within fan, but you're not able to because I is from a different package. So different package, and that's the reason why you cannot different package and child means you can only access through inheritance but not through containment. So you cannot access I through containment. Methods with variable argument lists. This is how you would declare type. It could be a simple type or a complex type, three dots, and followed by space, followed by the name of the variable, and this should be the last variable in a list of method arguments. Variables could be primitives or reference variables. Final variables should be defined before a constructor ends. Volatile variables. So the keyword volatile tells JVM that a thread accessing the variable must reconcile its private copy of variable with a master copy in memory. Things that can be marked static. Methods variables, a class within a class but not within a method. So if I have a class within a class, that class can be marked static, but if I have a class within a method which is defined in a class, I cannot have the class within a method as static. Init blocks could be static. Things that cannot be static are constructors, for obvious reasons. Classes, that is only inner classes. Only inner class could be marked static but not within a method. Interfaces cannot be static. Inner classes, so if I have an inner class, the methods within inner classes or the instance variables within inner classes cannot be marked static, and local variables cannot be marked static.